Welcome to Chapter 1B Review, Mimeo, YouTube video here. In no way, shape, or form is this the same as Chapter 1A. It is actually unequal to Chapter 1A. That was a joke. You can laugh at that. But yeah, we are working at equalities here. And the biggest thing I want you to know before we even start is that to finish a problem, we want you to solve and graph, and then we want to get it into interval notation. So the graph and the interval notation is really all part of the solution. So looking at this first one, this is what we call a compound inequality. So what we want to do in the first one is try to get x by itself in the middle. So we can do that by adding 2 to all parts. So we're going to add 2 to everything. Again, I'm not always going to show all my work here because it's a little tricky with the space provided with this tablet. So just listen to my words here. Negative 17 plus 2 is going to put us at negative 15. And that's going to be less than 3x, which is less than 63. And then when we divide everything by 3, a positive 3, we're going to get negative 5, which is less than x, which is less than 21. So I've got my 2 boundary points here at negative 5 and 21. And this is a compound inequality where it shows all of the values are between negative 5 and 21. And it's not including, so we're going to use parentheses on both parts there, and all of my solutions are in between there. Interval notation would be negative 5 all the way to 21. Please don't forget, interval notation is showing all of the values that work, every single value in here between negative 5 and 21, not including negative 5 and 21. All of those values, when you plug it in anywhere here, will come out to a true statement. Anything in these other regions will come out to a false statement. Okay, so moving on to the next one, there's a little wrinkle to this one. You can see with the negative 2 coefficient, we're going to subtract 4 from all parts first. So we'll get negative 6 is less than negative 2x, which is less than or equal to 2. And then now I will show this when we divide by negative 2. Anytime you divide by a negative value, we have to, think of it right now before I say it, switch the sign. So we have to switch that sign, and then we have to switch this sign so that the problem reads like this. And you can definitely go plot it like that. A lot of people will want to rewrite it. I do. I like to rewrite it with the value on the left where it would be on a number line. So reading it backwards here, negative 1 is less than or equal to x, which is less than a positive 3. So again, plotting that on here, we're going to get our negative 1 and our 3 less than or equal to 1. So we're going to have a bracket on the negative 1, all of these values up to 3. So interval notation is real simple off of the graph, negative 1 to 3, parentheses. All right, moving along. Now we're going to get into an absolute value problem. With the absolute value problems, we are going to do, and I'm going to highlight this so you remember, the true-false testing method, okay? So we're going to test true-false when then there's an absolute value. So it looks like these next few problems we're definitely going to be doing that. So looking here, it's already set up. We're looking for a possible distance greater than or equal to 10. So absolute value tells us that the first thing we do to solve these is to split, and I kind of pretend there's an equal sign there. So what I'm going to do is I'm going to come up with my boundary points here by actually splitting the problem as if it actually said absolute value of 6 minus 4x is equal to 10. So when we do our split, the only thing that changes is that this second one we have a negative 10. So now solving each of those, we're going to have negative 4x equals 4. We'll get an x value of negative 1. And then over here, negative 4x equals negative 16. And x equals 4. So those are actually my boundary points for this problem, okay? Because those are the solutions if it were an equation. So what I'm going to do is I'm going to take negative 1 and I'm going to plot it on here, and I'm going to put 4 on here. And now I'm going to test my regions. I'll do that work in red here. So the easiest one, you can do these in order, but the easiest one is the value of 0, which is in this middle region here. So if I put a 0 in, now where do I test it? I'm going to go back to the original problem. So I'm going to talk my way through this here. If I'm testing 0 here, if I'm testing that value, I would have the absolute value of 6 minus, well, 4 times 0 would be 0. Absolute value of that greater than or equal to 10. And we're looking for a true or a false statement. So 6 minus 0 is 6. Absolute value is 6. So we say, is 6 greater than or equal to 10? Obviously not. So the value we tested right here of 0 came out false. And any value you would have picked in here would come out to the exact same false statement. Depending on where you picked, it'll just be a false statement. So then we're going to test the other regions. Well, if I put a 5 in here, so I'm going to talk my way through this more than do it. Just listen to the words. I'm going to put in 6 minus 4 times 5. So what that's going to be when I test, oops, sorry about that. When I test 5, okay, this is my test of 5, I'm going to have the absolute value of 6 minus 4 times 5, which is 20. And I'm going to compare that to 10. 6 minus 20 is negative 14, but the absolute value makes it a positive 14, greater than or equal to 10. So that's going to give me a true statement. Likewise, I can pick any point over here, and when I test it, it's actually going to come out to be a true statement. So I do want you to try those in practice, but I'm going to save the time now. It does come out to a true statement. So what we're going to do is always shade the true areas. And then I look right up here, and it's or equal to in the problem, so that's the brackets there. So I'm going to shade the trues, and I'm going to be using brackets. Not bad. Brackets here. So interval notation for this problem would be parenthesis, negative infinity, all the way up to -1 with a bracket. Sorry, that's a comma there. All right. Union, which just means or. That's all that means. And then we have 4 in brackets all the way to infinity. There are a lot of possible answers to this problem, and that interval notation represents those answers. Okay, likewise, number 4, going to move a little quicker now. So now we have 2x plus 5 equals 11, or 2x plus 5 equals negative 11. And we're going to solve 2x equals 6. We're going to get our 1 boundary point of 3. And then 2x equals negative 16, we'll get our boundary point of negative 8. So we want to put our negative 8 obviously on the left and the 3 on the right. And now we're going to test our regions. So I'll go to the red pen here and we'll talk our way through the region testing. Again, 0 is convenient. You can pick any of these values, you just can't pick the actual boundary points. It has to be in the region. So if I put in 0, I've got 2 times 0, which is 0, plus 5, which is 5. Absolute value of 5, which is less than or equal to 11. So that is a true region. Now, intuition might lead you to think that these two would be false. I would always just, until you know with 100% confidence, exactly what works out, I would just test them. It doesn't take long. So if I put in a 4, I get 2 times 4, 8 plus 5, 13. Absolute value of 13 is less than or equal. That's false. And then if we do negative 9, negative 18, plus 5, negative 13, but the absolute value is 13, which again is false when compared to being less than or equal to 11. We also have brackets on this problem because of the or equal to in it, but we're going to shade the true region. So interval notation is this region in here, basically saying any values between negative 8 and 3 will work for that problem. All right, finished worksheet, front side of this worksheet here, by just realizing you can't do your split. Doesn't make sense yet with the absolute value logic that we're using until we have the absolute value alone. So the first thing we have to do here is subtract 4 from both sides. So now I have the absolute value of 2x minus 2, and I'm saying that's less than negative 1. All right, well at this point we really got to understand the logic of absolute value. And I'm going to do this in blue over here to the side. If I have the absolute value of x equal to 5, with an equal sign, that totally makes sense because we can put in 5 or negative 5 to get a true statement here, okay? But if I make this a negative 5, there is no value that we can actually put in there that would actually get a negative 5. So if we were solving this equation, we would say no solution. Well, just so you're aware, with inequalities, I don't know if this is connecting yet with you, I hope so, but if I have something like this, this is where, up here, this is where are the point or points that have a distance of, and when it was positive 5, we'd say 5. This is saying we want a distance greater than 5. Well, if you think about this, there are distances on the number line, like the number 6, for instance. That has a distance greater than 5. So does 7, so does 8, and everything up to infinity. Well, on the other side of the number line, there are a bunch of values as well that give me distances greater than 5. So actually, if I was looking on a number line here, and I had like 0 here, The 5 is here. The negative 5 is here. And I hope it's ringing a bell that we would shade everything here and shade everything here for this, because all of these numbers have distances greater than 5 from 0. And I hope that makes like a little connection to you on why we're doing shadings. Okay, long story short, if I had the absolute value of x and I said like less than -1, I'm in essence asking you what values have a distance smaller than -1. That makes absolutely no sense. Distances are always a positive value. So this doesn't even make sense, the question being asked. And why am I going over all of this? Because look at this problem. We have the absolute value here less than -1. And that really doesn't make sense because we're asking a question for a distance smaller than -1. So in this case, we would say no solution. It's the same thing as if we had an absolute value equal to a negative. Same logic leads us to no solution on that. Okay, so all that blue there was like an extension, hopefully getting you to connect a little bit of math, and I hope that made sense. Okay, moving along here, we're going to subtract 13, and I'm going to show this because this is where we kind of mess up a lot on these first initial solving before we actually do our split. So we've got here less than -15. Now, if you understood that before, we said, hey, you can't have less than a negative. But be careful, I'm not there yet. I still have a -5 looming here. And people want to add this 5, but there's a multiplication there. So you have to divide both sides to undo that multiplication. And as you can see, when I divide by a negative value here, two things are happening. First of all, I get the 2x minus 7 alone, which is great. Okay, but then I divide it by a negative. So that less than is going to turn into a greater than. And -15, I have no idea why I put a -15, sorry. Divide both sides by -5, I'm glad I caught that. That's going to be a +3, but we had to flip the sign here. Okay, so be very careful with understanding that this sign just turned to that because we divided by a negative. Okay, moving along. So now I'm going to have my split. I'll have, and this is just like before, 2x minus 7 could be 3, or 2x minus 7 could be -3. When we solve each of these, add 7, which will give me 10 divided by 2, I'll be at 5. Add 7 at 4, divide by 2, I'll be at 2. Skipping ahead there. 5 and 2 are my two boundary points. So there's 2, and there's 5. And I'm looking for regions that are true, false. Now, when we test these values, I did this in red, we're going to test 0, but this time be careful because 0 is not in the middle region. 0 is over here. Now, we could go back to the beginning, and that would work out well. I like to go to this step right here because it's easier. You need to be confident in yourself that you switched the sign correctly, that you made no mistakes to this point. Because if you made mistakes and you're testing in something that's wrong, you can run into issues. But if I throw in 0, I'll get -7, absolute value 7, which is greater than 3. So this is giving me a true statement. If I put in 3, 3 times 2 is 6. 6 minus 7, that would be the absolute value of -1, which is 1. And when I compare 1 greater than 3, I'm going to say that no, that's not a false statement. Pick a value on the right, and you're going to see that that comes out to a true statement. So this one is a parenthesis problem. So we're going to shade everything in this region, and we're going to shade everything in that region. Interval notation, -infinity, comma 2 with parentheses, or 5 to infinity. Okay? And now at this point, I hope that in yellow, we'll go in blue here. I hope that your understanding of this, if it was here, it's progressing towards here. And you are still having fun doing math on YouTube.